Nowadays, we see a trend to a more and more digital exchange. And this is where exactly we would like to go with you a step further. Welcome to the first Lenze webcast from trend to reality. My name is Anna Brunzel and I'm a marketing manager in systems at Lenze. The webcast series from trend to reality will highlight all the trends you in the mechanical engineering are facing nowadays, and we will talk about concrete solutions. In the live webcast, you have the possibility to chat live with our experts, and some of your questions we will raise in the live webcast towards the end. After the 30 minutes, our experts will remain in the chat, so you can still raise your question and go even in a deeper discussion. The topic today is the digital challenge in mechanical engineering. Who of you thinks, yes, I know the digital transformation is fully in progress, but how can I really use this tremendous potential here? And who of you thinks, what are the real and concrete solutions I can offer my customer today? To go to the bottom here, I have invited two guests. This is Dr. Hans Egermeier. He is consultant in the automation industry and the expert in terms of digital transformation. And Martijn Theunissen, as head of application and support at Lenze, he can share his experience of thousands of customer projects. Welcome, Hans. Welcome, Martijn. Would you like to introduce yourself too?
Yeah, of course, Anna. Pleasure and honor to be here and to address our dear customers over this, let's say, new format for us. Yeah, let me start with, as you know, Lenze is a global company. Yeah, and that means that we are looking for, let's say, international opportunities when it comes to allocating our global responsibilities. Yeah, and that means that it's my pleasure to welcome you from my office in Zertogenbosch in the Netherlands. Yeah, my name is Martijn Theunissen, and like Anna said already, I'm globally responsible for all our engineering teams, yeah, that are on a day-to-day basis working with our customers, innovating their machines, working on new machine designs and implementing our systems. In case you are wondering what is behind me at the wall, yeah, developing ideas. Two things, yeah, that implies very strongly to me as a person, always looking for new ideas to come to the next level. But the stage developing ideas in a project, yeah, is also the most interesting part, isn't it? Yeah, doing something new. And doing something new and digital challenge as a topic for this webcast is also a topic that you as a machine builder cannot do on your own. Yeah, this is an era of networking, of being challenged, getting external impulses. Yeah, and we have I've met Dr. Hans Egermeier, Hans, in a number of projects that we are doing together with our customers. Yeah, and therefore we are very happy to introduce also Hans to you in this webcast or webinar. Hans, please.
Martijn, thank you for the short introduction. Well, to my person, I'm Hans Egermeier. I'm a mechanical engineer and I studied also production technology. So my heart is really beating for the mechanical engineering. But my whole professional life, I was developing software systems, large software systems with bigger or with large teams and distributed teams. Since 2016, I'm now consulting companies, OEMs, machine builders, and automation companies or automation system suppliers on their way to the digital transformation from a strategic perspective, but also very on an operational level. How get we things done for the digital transformation?
Thank you. It's a pleasure to have you both in the call.
Thank you.
Without further ado, let's just dive in the topic. Hans, what are the challenges that OEM are facing today?
Well, the challenges, I think they they're not so much different than the core challenges of the past. We as consumers, we are driving we are one of the biggest motivations for the machine builders and production technology, because we want to have differentiated, specialized, individualized products. This leads to production systems that can handle all these variations, but we don't want to pay too much. So machine builders now are facing the challenge handling a lot of variations and specializations, but producing things for the cost of batch for the cost of mass production. So when we see in this little graphics, so what's the driver? The driver is that over time, the cost for small batch sizes, or to the extreme batch size 1, needs to drop down to the level of mass production. And well, the challenge is now for the machine builders, or was all over the time, the level of machine flexibility needs to rise or needs to increase. And here comes the digital transformation now into play, or comes in. And so what do we get? I think we get a lot of nice presents from the IT technology. For example, we get low-cost computing power, so CPUs or PCs or laptops or PLCs. So to make the brain cheaper of a machine is now easier than for former days. Or we can store a lot of information. Now, to store a terabyte is not that expensive anymore. Or we have access to algorithms that can handle this information. And last but not least, we get cheaper connectivity for the machine, so we can let the information flow. So to put these technical innovations together, we can make our machines smarter. And by this, we can increase the level of machine autonomy and flexibility. And therefore, this is the loop back. This helps us to decrease the costs for small batch sizes. And well, I think this is the round trip we have from the market of individualization now to smarter machines and the nice technology that helps us to get there.
Mm-hmm. Let's take the time to dive even deeper. So, to what extent can digital transformation help here?
I think it's an enabler. It's not more and not less. And if companies are willing to take this enabler and build this into their machines and to make their machines smarter, they can be the leading ones. And but I can also just sit aside and look. So the digital transformation it's an opportunity for us, and we should take it.
Mm-hmm. And where do we stand today?
I think it's hard to generalize all over the companies. There are some companies they're really pushing and they're actively pulling the technology from the IT side to their operational side, building strong CPUs in their machines or using the latest algorithms in order to do some nice data analytics. So these are the ones that are leading and they understood what's going on. But still, I think we are seeing a lot of companies, they sit and wait and hope so that there is maybe the next step of Industry 4.0 is done and they can just take it. But this is not the game. I think we need to actively push, and the companies that are willing to push, well, they can just do and start right away.
Thanks on expanding on that. Let me ask a last question to you now. It's the digital twin seems to be the central point in the whole discussion. And what is the most important to cover here?
Well, thanks to bridging to the next topic, to the digital twin. I think this is the contradiction we have to take into account, because if we want to make machines smarter, we need to be able to handle a lot more complex systems. So it's not only the physical process now we need to manage. But now the machine is just one part in a bigger information technology system. So this makes it just harder to engineer. On the same time, we have the challenge that the engineering process needs to get smarter and cheaper, because in order to be economical or to be on a cost level also in the engineering process. And I think the option or the possibility we have is that we model or we simulate a lot upfront so that the cost of physical prototyping can be reduced. So here's the digital twin. So the digital twin is the idea that we can evaluate or simulate almost the whole machine or the whole production process upfront before even like the first screw is physically screwed somewhere into the machine. This we see on the right hand side. If we talk about a digital twin, this involves a lot of different models, starting with maybe some easy or some just 3D functional mock-up. It's just look-alike and no behavior, no intelligence. Going through all the construction and designing and engineering process, covering the domains of like software engineering, electrical engineering, mechanical engineering, ending up doing the whole simulation of the whole system, and doing the virtual commissioning in the end, so we can simulate everything and really commission the machine in the computer. And then we can, when we start the machine, everything is evaluated and we can just build it up, download the software, and hopefully everything's working. So it's the digital twin covers a lot, and the more it can cover, the better it is, and the more value it has for the machine builder.
Thank you. Thanks for expanding on that too. Martijn, you are sitting on the customer side. So what is your experience? Where do our customers stand today?
Well, I think Hans said it already. There is no generic answer. There is no answer for the average customer. I would say, although that Industry 4.0 and configure to order are, let's say, topics that are on the top of our mind already a couple of years. Machine builders are very, from their historical DNA, very mechanically oriented. And when it comes to modularization, standardization of their machine portfolio from a mechanical perspective, they have progressed a bit more than from a software architectural perspective, I would say. But of course, there are very, let's say, advanced customers in the market, and there are the ones who are waiting.
We are talking here in this context a lot about the future solutions. What is the value that Lenze can offer their customers today?
Yeah, let me share two pictures there. Give me a sec. I would like to step into real concrete examples of projects that we are doing with our customers. I think that is the most interesting part in the end for our visitors or listeners. To start with that, to introduce that, here you see in a nutshell, this is what we offer to the market. On the right hand side, you see our automation platform. Consisting of the machine controller in the center with all of their interfaces, let's say northbound into connectivity, vertical integration of the machines into the production infrastructure, remote monitoring and diagnostics and data collection into a cloud infrastructure, and southbound, the data connectivity into the machine, to the field level, and the field components. And here I would like to mention, I think one of our next webcasts is a more deeper introduction of our automation platform, and also to dig deeper into the topic of, but we're all talking about IT meets OT, information technology meets operational technology. The automation pyramid in such is changing a bit. These worlds are more connecting, and here we have created I would say a cool solution for the machine builders how to implement that very practically into their machines. So that is I would say the automation platform. Then if you ask me what differentiates Lenze from any others, I would say that is the way we work together with our customers. This is more than creating and developing an automation platform, putting it on the market, having some nice marketing around it. This is about joint implementation projects our domain knowledge in our sales engineering teams, in our application engineering teams, to really work from the early stages of a project. Remember, developing ideas until the real implementation of the machine over the whole life cycle of the project. And that is what differentiates us, I would say, from many others. And then to go to the next picture. Real examples. Hans mentioned batch site 1 and the digital twin. And basically these challenges are not new. The challenge batch site 1 is not new for the machine builder, of course. Many machines are, or most machines are, of course, unique. An end user, a production company orders his individual machine with the option modules that he needs for his production process. And the question is, how can we realize this batch size 1, this unique machine, at the cost of a serial production machine? And there, let's say the possibilities of digital engineering and the digital engineering process come into place. To give you a real example of a project that we are executing right now, let me take you mentally to a machine builder in the printing industry in the south of Germany. A printing machine as such, is per se a machine that can be modularized very well. A lot of option modules and a base machine that is always consisting, so to say. And from a mechanical perspective, this machine builder had his machine framework, his portfolio, already in place for a couple of years. But from a software perspective, machine software perspective, it was still a monolithic approach. And here we have, over the course of quite some workshops and sessions, come to a joint software architecture, of course, using our automation platform, our fast modular software framework, to define the functionality, the interfaces for the base modules, for the option modules, to come up with let's say a mechanism how to activate these option modules in his software ecosystem. And that is a totally different approach than just creating the next machine on the shop floor. It's a real 360 approach. What is the offering, the machine portfolio offering of the machine builder, and how to implement that? And if you remember the picture from Hans very well regarding the digital twin, it does not start from the implementation process. It starts from the sales process. And here the question is, how can the machine builder implement a systematic in his processes, in his teams, in his sales teams, basically, to efficiently secure, bring offers to his machine builder without, let's say, compromising the machine portfolio that he has defined. And there we have, within the Lenze group, we have the Lenze Anchorway as a company, and Anchorway is one of the market leaders when it comes to configure, price, quote. So they are able to define the machine portfolio, the machine option modules, bring that into data models and optimize your offering process. And that, together with the implementation into the Lenze automation platform, together with Fast, makes batch size 1, I would say, a bit more affordable. So that would be the topic, or one example of the topic, how to approach batch size 1 as a challenge. If we go into digital engineering very shortly, Hans said it already. The simulation models. It's a matter of what is the real use cases that you want to optimize. There is no such thing as the digital twin as a huge tool or such. It's always about what is the relevant use case that you would like to optimize, and then optimizing that specific challenge. 2 examples. We are working with a machine builder in the textile industry. A very, very dynamic process. And here it's about finding the optimum between the machine mechanics and the automation solution, servo solution. And that at an optimum cost point. So running as much iterations as possible to find an optimum without having to build 100 different prototypes. And what we are doing here is the OEM is taking his MATLAB models, in this case, of his mechanics, vibration analysis, and so on. And we are taking the whole, let's say, automation modeling, from set point generation, from motor control perspective, from a thermal models of drives and motors, and then doing a lot of iterations in a very short time to find an optimum. So that is one example of how to use simulation in a joint project. And I know you're looking, and I know time is running, but I can go on and on with examples.
Yeah, exactly.
We are doing with 300 engineers about 1,500 new machine designs a year. How many do you want?
But you know what is really cool? After the webcast, you can still go into deeper discussion with our customers in the chat, or even by phone or email. So no worries. I'm sure you will get your chance to go deeper.
Right.
You just said the keywords digital twin, batch size 1, etc. And I wonder, where do we stand today in terms of Industry 4.0? I mean, we are stressing this word and this concept since almost 10 years now. Where do we stand today, and what is there to be expected for the next decade?
I think this is a good question. If we think that 10 years or since 2011, it's quite a long time. So we should expect that a lot changed. Now, I think it's when Industry 4.0 as a word was created, or as buzzword it was created, a lot of people were thinking that this can solve any kind of production or machine building problem at once. This is definitely not the case. But I think we definitely saw an acceleration of technology that was integrated in ideas and standardization that is used and built up and created now. So, for example, if you have a look at the standards that are almost ready to be used, or that are already used more and more, for example, E-class, standardizing the description of electrical components or electrical artifacts. Or if you see, for example, OPC-UA. 10 years ago, OPC-UA was still in a sort of small niche, and up to now, it evolves to become maybe the one and only field bus we have. So it's really about standardization, and I think we can also see that the big companies are pushing now. They see that working in a proprietary field is just too small if you see it in the context of the digital transformation. So we all need to open up, and I think the big companies, they did, and we can see step by step now the advantages in exactly these kind of technologies and standards.
And what is your views on that? What can be expected in the next 10 years?
Oh yeah, may I answer?
Sure, please.
Yeah, maybe as an example, if you look at, I mean, we are talking a lot about optimizing the machine, by logging machine data out of the machines into a cloud infrastructure, and then comparing the machine behavior and benchmarking other machines and so on. And I would say 3 years ago, if you would ask the customers, where are you on that perspective? There was a lot of hesitation. If you ask them now, we did a workshop with a couple of machine builders a couple of months ago, and the statement is that in the next 3 years, 75% of the machines will be individually connected to the cloud. So mentally, we are also changing. And this leads, of course, to a lot of new possibilities, changing the let's say, creating creating more revenue streams over the life cycle of the machines. So I think that we are still on the verge of going to the so-called connected machine.
Let's have a look in the chat. I see that we have first questions there, so feel free to raise even more questions. We have one question regarding model-based engineering and the digital twin. Where is digital twin evaluation and proving found in this model?
I think, Hans, we are both. unsure what the question really means, to be honest.
Same to me. So does it lead to the problems of the digital twin and like how to get there in an economical way, or does it lead to like where are the gaps and the like the missing parts in order to get there? So what do you think? In which direction is this question heading?
We don't know exactly, so maybe the one who's asking could just elaborate a little bit more. Meanwhile, I will just have a look what further questions we have. Somebody's asking, everyone is talking about software becoming so important in the mechanical engineering. But if I look in the program team I am facing in my company, I see that the reality looks quite different in terms of capacity, workflow, etc.
Well, I think it's as always, we cannot generalize. I think every single company is doing a little different or handling this topic a little different. But what we can see is that mechanical engineering is most often still the leading factor, which is okay to a certain extent. But software, if you see software teams, they need to work in a little different way. So they perform better if you work in an agile workflow, and they have little different tools, different mindset, different organizational structure. So I think here we should speed up a little bit and also shift our mental mindset, not to stay on the mechanical, like pure mechanical side. We should open up and also integrate the mindset and the ways of thinking and doing of the software. This will help a lot, because if we just talk about software, it's just we get it not done. We need the software teams and lead them in the right way.
Yeah, and maybe as an addition, yeah, I know how it is in real life. Yeah, these small software teams at the OEMs, they are struggling a lot. Yeah, with bringing all the machine orders, getting them ready. Yeah, meanwhile dealing also a bit with problems in the field. And it starts with small things. Yeah, I would say start talking to your colleagues about a common architecture. Yeah, and spend a small percentage of your time and making software architecture a topic that you discuss. Yeah, and create step by step a vision for yourself. Where are we right now? What are the main challenges that are coming at us? And therefore creating a common picture on what needs to be done. Yeah, and don't try to close up all your software coding. Yeah, but be willing to speak about it as a joint challenge, yeah, within your team, and that gives you also the possibility to make your management aware of what needs to be done.
I think this is a perfect example, because the most common anti-pattern for software development and machine building is you have one guy and one machine. And so if you have a lot of machines, you need a lot of different PLC programmers, and they're not able to do exactly the thing Martijn said, to talk about a common architecture, to talk about modularization. And we learned from the IT and the pure software development that this is not cost efficient. You need to bring teams together and people together in order to be really fast in software engineering.
Thanks a lot. Time is running, so unfortunately we are coming to the end of our webcast. But as I said, the experts, Martijn and Hans, they will remain in the call to answer your question. So far, thanks a lot, Martijn, and thanks a lot, Hans, for being our guest today.
I would say thanks to our visitors.
Thanks a lot.
Very good. So we heard today a lot about Industry 4.0, batch size 1, etc. And let me just wrap up the key takeaways here. What we could learn is that the digital transformation is really fully in progress. And if you are not on your way already, you should hurry up. The first key takeaway. The second is, don't try to do everything by your own and in-house. It is really important to have a good partnership here, and this is really the key factor to success. And the third key takeaway from my point of view is that the digital twin is not easy to be realized, but it's really worth it. So keep on working on that. If you want to dive deeper in the topics of digital twin and digital challenge, you can find some white papers on our website and go even deeper in that topic. I'm sure you have plenty of questions that you would like to discuss with Hans Egermeier and Martijn Theunissen. As I said, they will remain in the call, or you can just give them a call or write them an email afterwards. They are happy to get in contact with you. I hope you did enjoy the webcast and could take with you some valuable information. And I would like to welcome you in the next webcast session too. You will find more information about the further topics we are planning on our website. And the topic for next week, by the way, is plug and produce.
Plug and produce, Anna.
Plug and produce, exactly.
So in a real life case of how to connect machines and machine modules, by using latest standards in OPC UA and companion specifications. So exactly. I can only recommend it.
Thanks for the teaser, Martijn, here. So now the call will end, but the chat will remain. Thanks a lot and take care. Bye-bye.
Bye-bye.